number 13. A beam of unpolarized light is incident on first of the two parallel polarizers. Okay, these are two polarizers. Let me call this as P1 and P2. Okay, the transmission axis of the two polarizers are initially parallel, which means what? So let us say this is the polarized transmission axis here, and this is also the transmission axis here. Initially they are parallel like this. The first polarizer is now rotated about the direction of the incident beam by an angle smaller than 90 degree. Okay, so first what we will do is let us assume that the incoming intensity here, unpolarized beam is I0. So it means, so after the first polarizer, the intensity received here would be I0 divided by 2. And if they are parallel here also, you will get I0 by 2 here. But here he says the first polarizer is now rotated by both the direction of the incident beam by an angle smaller than 90 degrees. Smaller than 90 degree means it could be, it's given an arrow here, which could be 45 degrees also. So as a result of it, what can happen? Okay, the polarizer might look like this over here. It might look like this over here, which means the polarizing axis, the transmission axis would be like this over here. Okay, now it is like this. Instead of being straight like this, now it is in this direction. Okay, and if you want, what I will do is I'll just rub this one here so that let there be a clarity. Right. Okay, now which gives the changes, if any, in the intensity and polarization of the transmitted light. Now what happens to the intensity if I rotate it like this? Now when in the transmitted light, okay, now initially when they were parallel to each other, what can happen? I0 by 2 will be over here, and here what can be the output? Output will be I0 by 2 cos squared theta. What is theta here? Theta is the angle between the two polarizer transmission axis. Initially this was the transmission axis of the second polarizer P2, and this was the transmission axis of the first polarizer. What was the angle between them? Angle between them was 0 over here. Thus the outcome here was seen to be I0 by 2. Now when I say this axis, I am just keeping it like this. For the P2 I am keeping it like this. But only P1 I am rotating it by a small angle like this. Small angle like this. Which means what? The angle has changed. As I told you, the angle was something like this. The angle has changed by an angle of 45 degree. If, for example, okay, it can be anything. I am just giving an angle of 45 degree. If this is 45 degree, then what will happen? The intensity here would be I0 by 2 into cos squared of 45, which is different from whatever we have here. That means definitely intensity changes, right? So intensity of the transmitted light will depend upon how you are rotating this one. So thus, this and this are incorrect. Either of them are correct. We are not interested in what is the value. We just want to see whether the intensity changes or not. Next come polarization. Now let us write here. So when you have an unpolarized light, the vibrations are confined to all the planes. Every plane the light is seen to be vibrating. When you keep the polarization axis like this, okay, when you keep the polarizer like this, now what kind of vibrations you get here? You only get vibrations which are parallel to the transmission axis. Now if I keep like this over here, I put one more polarizer here. What is the outcome here? Outcome will also be like this. Outcome will be like this. This is in the case of the first setup. In the second setup, now what is happening? You keep the polarizer like this. You keep the polarizer. Let me rub this and show you. It's taking some time, but for the sake of clarity, we can go ahead with the timings. So let us have a polarizer like this over here. Transmission axis is like this. So once again, unpolarized light, right? Unpolarized light, when it enters to it, now what will happen to the polarization here? It gets plane polarized in this direction, right? In this direction. And when this is unaltered, and you have like this, then what will happen? Not all the vibrations will like this. There could be a few vibrations which are in this direction also. Only vibrations which are parallel to this will be seen here. Which means what? You see, these lines are the same, identical as this one. But maybe in a short range over here, let us say if there are 100 lines like this, 100 vibrations are here. Here you might get only something like only around 10 lines over here. Why does it happen? Because which tells you intensity is different. But the vibration is always one and the same. So which means that the polarization is not getting affected, right? It only depends upon this axis over here. The intensity definitely gets affected. So which is the right one? A is the right one over here. Polarization same, intensity is different. So A is the right one.